electricity. Of course, for this case, this argument is not advanced so much. For that case, we shall just reserve it for another topic of maybe electricity and chemicals, which is electrochemistry. But then after Michael Faraday's argument, there's another scientist now who came and employed some of the scientific methods. Now, by scientific methods, I refer to observations, experiments, theories, and maybe they came up with principles. So in actual sense, this one performed an experiment. So this scientist by the name J.J. Thomson discovered that after performing an experiment that atoms have negative particles, which he referred to as electrons. So J.J. Thomson was able to successfully discover the existence of electrons by performing an experiment using what we call a cathode ray tube. So for that case, if I just make a small demonstration here, we have a tube. And these are plates. Of course, these are charged plates. And this is a cathode. Cathode refers to as negatively charged, just an element which generated cathode rays. So these cathode rays, when they are just emitted from the surface, Thomson observed that some rays are deflected towards this is a positive plate, which is known as the anode. This is the cathode. So he observed that these rays are attracted towards that, and from the law of attraction, it goes by default that definitely those rays exhibit a property of maybe matter that is negatively charged. So in this case, he was able to describe these particular particles as electrons, and they measured the electron charge to mass ratio, and they found, so mass to charge ratio, we found it to be 1.76 times 10 is to power 8 coulombs per gram. So in this case, we are trying to see some of the analytical methods which are being developed with time, starting from the time of J.J. Thomson. Of course, there are some which will have been done, but for this case, we're seeing that J.J. Thomson is able to perform an experiment that describes the existence of an electron. Now, from his conclusion, Thomson came up with what we call a visual representation of what an atom looks like, and they called this one the Plum pudding model of an electron, of an atom, sorry for that. So he argued that in a Plum pudding model, electrons are uniformly distributed amongst the positive charges, or dispersed in uniform in the positive charge, in the space of an atom. And that was the model that he came up with, that we are calling the Plum pudding model. Of an atom. So as you can see, now scientists are trying to come up with a visual representation of what an atom looks like, and this is the Plum pudding model that is being developed by J.J. Thomson. Now there was a